Welcome to today's session on the index laws. Some of you may know these as the laws of indices. So what we are going to be looking to do with these is that we are going to be playing about with our indices. Now some of you may remember that indices, that's another word for our powers, our raised numbers after a base number or base letter. Some of you may know them as exponents, and some of you may know them as order, who've gone and done maths. So our first law to remember, I'm going to go over the four laws, and then I'm going to go over the second fours. So the first of the four laws is anything base number or base letter to a power multiplied by the same base number or letter to a power, it's going to equal the base number or letter to the powers added together. So an example of this, I've got a to the power of 3 times a to the power of 2. So the base letter stays the same, which is a, and we're going to add our 3 to our 2, which is going to be a to the power of 5, and this is now simplified. That was multiplying, as opposed to this is when you are dividing. When you are dividing and you've got the same set out question, you subtract your powers. So using the same question, a to the power of 3, but this time dividing by a to the power of 2. Again, the base stays the same, which is a, and we're going to subtract 2 from 3, which gives me a to the power of 1, which many of you are probably aware that we can simplify this further by just writing a. Our next law is that we've got, anytime we've got a base letter or number to a power inside brackets to a power outside the brackets, the base stays the same, and we just multiply together our two powers. So I've got a to the power of 3 inside brackets, all this is to the power of 2, so we've got a 3 times 2, which becomes a to the power of 6. And our last of the first four laws is that anything to the power of 0 always equals 1. So here I've got 15,635 to the power of 0, that still equals 1. Now maths all time by students, why is this so? This doesn't make sense. Why does something to the power of 0 equal 1? In which case this is the best explanation that I can use, which works well with my learners. So here I've got a to the power of 3, reducing in power each time down to a to the power minus 2. Now underneath I'm putting down exactly what these represent. So I've got a to the power of 3 is a times a times a multiplied by itself 3 times, all the way down to a to the power minus 2, which is 1 over a squared. This will become more relevant when we look at next four laws. But as we are going down by a power, each and every time the power is reducing, we are dividing each of our expressions by a. So here we've got a to the power of 3, which is a times a times a. Dividing that by a gives us a times a, which is a to the power of 2. Reducing our power by 1, dividing this by a, that leaves us with just a. And for the next step, reducing our power by 1 to 0, a divided by a, that leaves us with just 1. Anything divided by itself is always 1. And as we can see, this continues to work again, because if we reduce our power by 1, which is a to the power minus 1, 1 divided by a, we can write this as a fraction, or literally set it as 1 divided by a. But it looks a lot nicer as a fraction, so 1 over a. And that's the first four index laws. The more complex index laws, there's 4 of them. We've got any number or letter to the power of a minus number, a negative number, is going to equal 1 as a numerator of our fraction over our letter or number to the power of our original without the negative sign. So as an example, I've got 2 to the power minus 3. So we're going to have 1 over our base number 2 to the power of 3. Now if we multiply this out, 2 times 2 times 2, that leaves us with 1 to the over 8. Our next index law is anything to the power of half means that you are square rooting that number or letter. So a to the power of half is the square root of a. As an example, I've got 81 to the power of a half. So square root of 81, that leaves us with 9. Third rule, now we're dealing more into fractions. We've got a to the power of any fraction where 1 is our numerator and we've got a letter or different number as our denominator. This becomes our base number or letter rooted to the power of our denominator, our bottom number in the fraction. As an example of this, I've got 8 to the power of a third. So this becomes cube root of 8, and the cube root of 8 equals 2. One way of trying to find that is whatever number would multiply by itself 3 times would give me 8. And 2 times 2 times 2 gives us this 8. And our very last rule, just an extension of this one, is that anytime we've got a number or letter to the power of a fraction where 1 is not the top number, we are left with the exact same. So we are rooting our base number to the power of the denominator or the bottom number in the fraction, but we are then putting all this to the power of whatever the top number is or numerator within our fraction. As an example, I've got 8 to the power of 2/3, which becomes, inside the brackets, cube root of 8, which we saw earlier is 2, and then whatever the result of this is, which is 2, we square this, so our answer for this would be 4. And that is all 8 laws of indices. Thank you very much for watching.